Hey guys, I'm Pat Kelly. In this problem, they ask us to find the solutions to this equation in the interval negative 2 pi to 2 pi, okay? Now, you might have already noticed some doodling I did off to the side here, or you recognize that, that's a unit circle. And I'll warn you, it's not perfect, of course, but this is a good tool to have for the thought process that's going to be involved in some of our work. So you might doodle something like that for yourself in your margin. But here's the work that goes into this type of problem. Is I have to solve this equation for x, right? And maybe I'm not that familiar with cotangent. And really I would suggest that it really helps a lot to break things down into the primary trig functions that you know real well, specifically sine and cosine. So if you're not that comfortable with cotangent, start off by rewriting it. You've got to know your identities, and in this case cotangent is the same as cosine of x over sine of x. And so this equation becomes, when does cosine of x over sine of x equal negative square root of 3? Okay? And the way they're going to answer that is with my unit circle, and I'm kind of glancing ahead and thinking that I know square root of 3, or specifically a negative square root of 3 is going to be involved. And I look at this, and I don't see square root of 3 anywhere alone. Of course, you know square root of 3 divided by 2 pops up in your unit circle in a couple of places. And so what that's going to motivate me to do over here in my algebra is to rewrite this so that I actually see a square root of 3 over 2 staring at me. All right? Here's how I'm going to do that. You might have noticed I left a little bit of a space down below here because I'm anticipating writing that over 1. Wait a minute, I thought you said over 2. The way I'm going to do over 2 is to rewrite again. I do still have the minus, but the square root of 3 I'll divide by 2, and I'm only allowed to do that if I balance that by writing that denominator over 2 as well. Algebraically, you know that you can't just jump in there and divide by 2, but I can if I balance it with a divided by 2 in the denominator. All right, now I'm in pretty good shape in terms of even looking at my unit circle and seeing that I'm looking for the cosine of x to be some kind of square root of 3 over 2, and at the same time, my sine of x be a 1/2. Okay? In fact, that's looking like this point right here. The cosine is my x-coordinate, the sine is my y-coordinate. And so this angle, your reference angle, is pi over 6. All right, you know that. All right, one more thing to address here, though, before I try to package up my answers, is that there is this minus sign. Okay? So I'm feeling really good about the fact that my fraction overall, where cosine's up in the numerator and sine's down in the denominator, is pointing me to the reference angle of pi over 6, but I need to be more specific in terms of which quadrant I'm in. And what quadrant I'm in is going to be dictated to me by this sign, S-I-G-N, just that minus sign right there. Okay? The way that I'm going to figure this out is by actually rewriting, I'm still carrying down this work, but I'm going to rewrite this fraction, this big fraction, really just by taking the minus sign and first just looking at it as if it's in front of the numerator and leave the denominator alone, or realizing that that minus sign could have been shoved down in the denominator, and so I'd have square root of 3 over 2 positive up top and a minus 1/2 in the bottom. The reason I like to think that way then is now I'm trying to figure out which quadrant I'm in. And in this first case, the cosine would be negative and the sine would be positive. That gives me my second quadrant, right? Cosine negative, I went to the left, and then sine positive, so I went up. So I know that reference angle of pi over 6, but in the second quadrant is one of my locations for the answer, one of my solutions. The other way that I wrote that fraction, here, where the denominator is negative, that would be cosine being positive and sine being negative, so that would be the fourth quadrant, right? Positive in this direction, but negative going down. My reference angle of pi over 6 then would be right there. That's where my two answers will be. Now I have to address the fact that I want solutions within that closed interval of negative 2 pi to 2 pi. Okay? So with our unit circle, we always start at 0, right, with the angle measure. And if I'm going to go to negative 2 pi, that's clockwise a full rotation of the circle. And the first place, if I now try to move forward, the first place I have a solution is that one that I circled in the second quadrant. Okay? Again, negative 2 pi is all the way around, but now I'm looking for answers, looking for answers, looking for answers. There's the first one. So my first answer here is x equals, and I need that second quadrant angle expressed as a negative, in this case 7 pi over 6. Again, that would be this angle. Negative 7 pi over 6 puts me there in that second quadrant where I was shooting for. Now let me try to keep the clock ticking here, and I'm going this way, still in my negatives for the angle measure, but I'm swinging around to that fourth quadrant. That's my second solution. So, comma. My second solution is I'm now trying to represent that pi over 6 reference angle, but in the fourth quadrant with a negative angle measure, and that's negative pi over 6. Comma. And I'm going to keep going, and I'm still kind of I'm moving counterclockwise though, and I'm now into 0 and positives. I'm heading towards that positive 2 pi, which is the end of my interval. I'm going to keep going, and I'm back in the second quadrant now, grabbing that answer right there, which would be a positive 5 pi over 6. Almost done, because then I'm just going to swing around, still going toward the positive 2 pi, and get that answer, which is going to be an 11 pi over 6. All right, those are my answers within that closed interval. Finally, I forgot to mention at the beginning of the problem, they wanted me to verify with a graphing utility. So let me grab my graphing utility now. And in my y equals, I need to enter the original function, which is cotangent of x. Depending on your utility, you probably don't have a cotangent feature. So I can do 1 divided by tangent, or I can even use this cosine over sine that I know that thing equals. I know the cotangent equals. So I'm going to do 1 divided by tangent of x. As my y2, my second function, I'm going to enter this negative square root of 3. What we're going to see is where they intersect. My window is negative 2 pi for the x min, a 2 pi for x max, a y min of negative 5, and a y max of 5. That should give you a good view, if you hit graph, of the cotangent function. And of course, the straight horizontal line is the negative square root of 3. And if you can find your window the way that I did, you'll see 1, 2, 3, 4 places of intersection. And those are our solutions. Okay. Thanks. I hope that helped.